Hello students, in this lecture we are going to discuss one example on the topic change to polar, and we know that here we have to change the Cartesian coordinate system xy into the polar coordinate system r and theta using the substitution, that is we have to replace x by r cos theta, y by r sin theta and dx dy by r dr d theta. Now we are solving one example on this topic, and the example is evaluate double integral from 0 to 1 and 0 to x plus y dx dy by changing to polar coordinates. First of all, we are writing this given double integration in details. So we can observe here upper limit and lower limit of the middle integral. We can observe both are the function of x, that means 0 as well as x both are the function of x. Therefore for this middle integral our y is varying, therefore we can write this middle integral as y equals to 0 to y equals to x. And clearly if y is varying, that is why we have to take integration with respect to y, and the remaining integral moving constantly, that is from 0 to 1. So for this integral our x is varying, so that this integral we can write as x equals to 0 to x equals to 1. And obviously if x is varying, that is why we are taking integration with respect to x. Now after that we are deciding the region of integration. Therefore the region of integration is bounded by y equals to x, that is nothing but upper limit of middle integration, y equals to 0, that is nothing but lower limit of this middle integral, x equals to 0, that is lower limit of outside integral, and x equals to 1, that is upper limit of outside integral. That means all are this curve are obtained from these upper limits of both integral and lower limit of both integral. Now we are plotting these curves on the graph. So one by one, the first curve is y equals to x, that is nothing but line passing through origin, and that is nothing but this line y equals to x. Next curve is y equals to 0, that is nothing but whole x-axis, that is this y equals to 0. Similarly the next curve is x equals to 0, that is again our whole y-axis, that is nothing but x equals to 0. Next curve is x equals to 1, that will be the parallel to the y-axis, so x equals to 1, that means this line. So these are the graph of this curve. Here we can find this intersection point 1 1 by taking the intersection of these two lines. Now here I have shaded one region, and that is nothing but the region of integration, and it is taken on the basis of the lower limit and upper limit of both the integral. That means using that middle integral, our region of integration is starting from y equals to 0, that is nothing but this line, and ending at y equals to x line, that means this line. So our region is starting from this line and ending at this line. Similarly from the outside integral, our region is starting from x equals to 0 line and ending at x equals to 1. That means our region is starting from this x equals to 0 line and ending at this x equals to 1 line. So this will be our common area. Now our next target is to change the Cartesian coordinate xy into the polar coordinate r and theta using that substitution, that is we have to replace x by r cos theta, y by r sin theta and dx dy by r dr d theta. So first of all we are changing our first curve, that is y equals to x. Our standard substitution is we have to replace x by r cos theta and y by r sin theta. So I am replacing y by r sin theta and x by r cos theta. So after solving this I will get sin theta equals to cos theta, and sin theta equals to cos theta means tan theta equals to 1, and it will possible only when theta equals to pi by 4. So the equation of line y equals to x can be written as theta equals to pi by 4 in polar coordinates. Similarly we can write this another curve y equals to 0, that means by replacing y equals to r sin theta we will get r sin theta equals to 0. So After solving this, we will get theta equals to 0. Similarly, the next curve x equals to 0, that means we have to replace x by r cos theta. So it will be r cos theta equals to 0, and after solving this, r will get at RHS side, so cos theta equals to 0, and cos theta will be 0 only when theta equals to pi by 2. Similarly, from the next curve, that is x equals to 1, we will put x equals to r cos theta. So the equation will be r cos theta equals to 1, and it implies that r equals to 1 upon cos theta, and 1 upon cos theta is nothing but sec theta. So the equation of line x equals to 1 can be written as r sec theta in the polar coordinates. So that all are the curves in polar coordinates. Now we are plotting a curve in polar form or polar coordinates. So here we can observe the second figure. Here the x-axis and y-axis. So on x-axis our theta equals to 0. That means here our equation is y equals to 0, and y equals to 0 can be written as theta equals to 0. So here theta equals to 0. Similarly, this line is nothing but y-axis, and y-axis is nothing but x equals to 0. So this x equals to 0 line can be written as theta equals to pi by 2. So this will be theta equals to pi by 2. Similarly, at LHS side of x-axis, your theta is pi. Similarly, at lower side of y-axis, our theta is 3 pi upon 2. Similarly, our x equals to y line, that is this line, can be written as theta equals to pi by 4. That means this line we can written as theta equals to pi by 4. And the last curve, that is x equals to 1, that is this line can be written as r equals to sec theta. That is nothing but this line, and the equation of this line is r equals to sec theta. So these are the graph of our region of integration in terms of r and theta, and our region of integration is this region. Therefore, we have to find our double integration using that region. And therefore, for this we have to find limits of r and theta. So for this I am taking one strip which is starting from this origin and ending at this line, that is r equals to sec theta. This strip is randomly, we can take anywhere. Now we can observe that our radius is starting from this origin and ending at this line. Therefore our r is starting from r equals to 0 and ending at r equals to sec theta, that is along this strip. That means our strip is starting from this origin and ending at this line. So the variations of r is nothing but r equals to 0 to r equals to sec theta, that is r varies from r equals to 0 to r equals to sec theta. And we can observe this whole region is belongs in between this line, that is line theta equals to 0, and this line, that is theta equals to pi by 4. Therefore our angle is from this line to this line is nothing but 0 to pi by 4. Therefore the limit of theta is nothing but theta equals to 0 to theta equals to pi by 4. That is, we can write as theta varies from theta equals to 0 to theta equals to pi by 4. And that are the limits of r and theta. Now from that limit we can write our given double integral as, that is our given integral is I equals to the integration from 0 to 1 and 0 to x plus y dx dy equals to theta equals to 0 to theta equals to pi by 4, and the another integral is from r equals to 0 to r equals to sec theta, that is from our new limits in r and theta. And the remaining part, that is x plus y, I can write as r cos theta plus r sin theta by using the polar coordinates, and we have to replace dx dy by r dr d theta. Therefore now we can observe that our whole double integral is in terms of r and theta. Now we are going to solve one by one integral. So here r cos theta plus r sin theta, we can take r common from this both the term. So if I take r common, then this 1r and this 1r will get r square. So this term will be cos theta plus sin theta into r square dr. Now this inside integral is with respect to with respect to r, so that for this integral our cos theta plus sin theta will be constant. So we can take this cos theta plus I sin theta outside, and the remaining part will be r square, and the integration of this r square is nothing but r cube upon 3. Now we are putting upper limit and lower limit, that is r equals to sec theta and r equals to 0. So if I put this upper limit, that is r equals to sec theta in that term, so instead of r we have to replace sec theta firstly. So this will be sec cube theta upon 3 minus, instead of r now we have to put 0, so this will be 0 cube upon 3. So this is upper limit and this will be lower limit. So upper limit minus lower limit, if you simplify it, we will get only sec cube theta upon 3. So in the next step I am taking this 1 by 3 is outside because it is constant. Therefore the remaining term in the integration is cos theta plus sin theta into sec cube theta. Now we have to take an integration of this term with respect to theta. First of all, we are simplifying this, and for this I am multiplying this sec cube theta to inside the bracket. We'll get cos theta into sec cube theta plus sin theta into sec cube theta, and we know that sec cube theta is nothing but 1 upon cos cube theta. So this cos theta upon cos cube theta is nothing but 1 upon cos square theta, and 1 upon cos square theta is nothing but sec square theta. So these terms we can write as sec square theta. Similarly, this term I can write as sin theta into 1 upon cos cube theta, and therefore this will be sin theta upon cos cube theta. And here addition is there in between these two terms, so that I can take the integration for these two terms separately, so that I am applying this integration for sec square separately and sin theta upon cos theta separately. Now to solve that second integral, we don't have any standard formula, and therefore we are using a substitution method. So if I substitute this cos theta equals to t, then this differentiation will be minus sin theta d theta equals to dt, and we want sin theta d theta at numerator side, so that I am taking this minus sign to RHS side. So we'll get sin theta d theta equals to minus dt. Similarly, we have to change the limit of this second integral also. So if I take theta equals to 0, and if we put this theta equals to 0 in that substitution, then we will get cos 0 equals to t, and obviously value of cos 0 is nothing but 1, so t equals to 1. That means if theta equals to 0, then t equals to 1. And now if I put this upper limit, that is theta equals to pi by 4, then cos of pi by 4 equals to t, that is I am putting theta equals to pi by 4 in that substitution, then we will get cos pi by 4 equals to t, and we know that value of cos pi by 4, that is nothing but 1 by root 2, therefore t equals to 1 root 2. So this t equals to 1 is the lower limit corresponding to theta equals to 0, and this t equals to 1 by root 2 is the upper limit corresponding to the upper limit, that is theta equals to pi by 4. Now we are applying this substitution only for this second integral. Now in the next step we are taking this 1 by 3 as it is. This first integral, that is integration of sec square theta, is nothing but tan theta, and this, by using this substitution, we are taking this another integral as 1 by t cube, that is the value of sin theta d theta is nothing but minus dt, that I am writing here, and we are putting cos theta equals to t, therefore this term I can write as 1 upon cos cube is nothing but 1 upon t cube. And taking care of this substitution, it is applicable only for the second integral. We are not applying this substitution for this first integral, so that we are taking this integration as it is, that is with respect to theta. But after this substitution, our integral of the second is this integration from t equals to 1 to t equals to 1 by root 2 1 upon t cube into minus dt. Now in the next step we are putting the upper limit and lower limit of this first integral, that is if I put theta equals to pi by 4 in tan theta, we'll get tan pi by 4 minus if I put theta equals to 0, that is lower integral, then we'll get tan 0 plus. Now we are solving this second integral, so if I take integration with respect to t, we'll get 1 upon 2 t square, that is minus 1 upon 2 t square, but one minus sign is already there, so minus minus will get plus. So integration of this 1 upon t cube is nothing but minus 1 upon 2 t square, and we are putting now upper limit, that is t equals to 1 upon root 2, and lower limit, that is t equals to 1. So in the next step, tan pi by 4 value is nothing but 1 and tan 0 is 1 plus. Now this 1 by 2 I am taking outside, that is this, and if I put upper limit, that is t equals to 1 by root 2, then 1 upon root 2 bracket square is nothing but only 2, that is here, and if I put lower limit, that is t equals to 1, that is 1 upon 1 square, that is nothing but 1. So by putting upper limit we'll get 2, and by putting lower limit we will get 1. So in the next step, this 1 by 3 as it is, 1 minus 0, that is only 1, 1 by 2 into 2 minus 1 is nothing but 2 minus 1 1, and 1 into 1 by 2, that is 1 by 2 as it is. And after solving this, so 1 plus 1 by 2, that is nothing but 3 by 2, and 1 by 3 into 3 by 2 is nothing but 1 by 2, that is our final answer. Thank you.